the only topic will be included talks about electromagnetic induction. In this lesson, we need to understand the meaning of EMF, how EMF is induced, what ways can be used to induce or to create, to produce electromotive force or EMF. We have two ways. Number one, either conductor moving across magnetic field or changing magnetic field linking with conductor. How? So the first way is either to have a coiled wire is connected to a voltmeter. What is the purpose of connecting the wire to voltmeter is to measure EMF or voltage will be induced, no current. So this is not considered as a current carrying wire, it's just a wire, has no electricity, no electric current is flowing in this wire. And once you move magnet in and out of this coiled wire, the pointer will start to be deflected. This means that EMF is induced. So this is the first method, which is moving magnet in and out of the coiled wire. The second method is if we have a magnet. Of course, magnet has two poles, north and south, and we have, of course, magnetic field. So if the wire moves across this magnetic field, so it will cut the magnetic field, this will cause change of magnetic field, which will be allowing EMF to be induced. So the idea here, when a wire moves across a magnetic field, if the wire will cut a magnetic field created by a magnet, this will cause magnetic field to be changed. When magnetic field is changed, EMF will be induced. So question 1 here talks about this idea. If we have a solenoid, which is a coiled wire connected to a very sensitive ammeter, a rod, we don't know the nature of this rod, it was just rod, it's not mentioned, is it a metallic rod, iron rod, is it a magnet or a magnetized iron, magnetized material. We know if we have magnet or magnetized rod, these two will just affect and will cause EMF to be induced. Just these will allow EMF to be induced if it will move in and out of this coiled wire. So then it's written here, the ammeter shows there is a small electric current. This means EMF is induced. So what are you expecting about the nature of this rod? So which rod is being inserted? Is it a heated copper rod? No. A magnetized steel rod? Yes. Because we have just mentioned either a magnet or a magnetized material will allow EMF to be induced. So it's magnetized steel rod. Which diagram shows a movement that will not produce the changing of magnetic field needed for EMF to be induced? So if we're going to diagram A, these two magnet will be inserted and the coiled wire will be moved across the magnetic field. So This is correct. This will induce EMF. EMF will be induced. Okay. Let's go to this diagram B. In this diagram, these two will be moving parallel to each other in the same direction. So in this case, magnetic field created by this magnet, because we know where is the magnetic field, direction of magnetic field. Magnetic field is out of north into south. Yes, as we studied before. So out of north into south. When these two, when the magnet and coiled wire will move in the same direction, this means magnetic field created by this magnet will not cut by a coiled wire, so no EMF will be induced. So what about case C? Here this magnet will move away from the coiled wire, so again magnetic field will be decreased, so will be changed, so EMF is induced. Moving a coil away from a fixed magnet, in this case magnet is fixed while the coil will be moved away, again magnetic field will be decreased, so there's a change of magnetic field, which means EMF is induced, which means these three cases 1, 2 and 3 will allow magnetic field to be changed and will help EMF to be created and induced.